Hi everyone, I hope the audio and video quality is good. Maybe let's wait 10 more seconds and we can get started. I'm quickly checking a few things. If the audio and video quality is good, please thumbs up. Thanks team. Cool. Let's get started. So today we'll be learning few things, which is taking any data sets like PDF, image, video, or it could be anything, and then we will extract some text from it, and then we will use some language model to answer from the text. So this process is called like chat with data. So in today's session we will explore few different options, like what are ways to secure our data sets, and what are some of the ways to use local and private models instead of using OpenAI model or other models. So I have prepared a Google Colab. In that Google Colab, I have used 3 different model types and then 3 different document stores and those kind of things. And don't worry about all these things for now. I will explain everything step by step. And at the end of the session, you will have a very good understanding about how to approach this problem. But before doing any programming, let's go to this one, playground.openai.com. Let me copy this and sharing here on Slack. Cool. So what we can do here is, so this is Playground. Here you can see a few things: complete, chat, insert, and edit. So I'm going to chat. Let me delete this. So here I am saying you are a weather assistant. I'm going to ask what's current temperature in Sydney and submit. It says I'm not currently able to access real-time weather information. However, you can check the current temperature in Sydney by searching online and other things. So the most important thing here is, if the language model has some context, it can answer well, because all these language model, what it does is, it's like a token simulation, which means it predicts the next word. It trained to predict the next word. So if you provide some context to the model will extract useful information, and it uses its reasoning capabilities and answer our question really well. All these language models like GPT4, GPT3.5 Turbo, the main advantage in those models is like its reasoning capabilities. So what we can do is, we can provide some context, then based on the context, it reasons and then it answers our question really well. So providing context is like a working memory. So I'm going to provide some context now. So let's say Sydney 15, Brisbane 20, Melbourne 13. Now I'm going to delete this. Now I'm going to ask the same question one more time. So it says the current temperature in Sydney is 15 degrees Celsius. So this is a very simple example. I used this to demonstrate what is context, why context is important. So when you deal with chat with data or any data sets, what you usually do is, you try to provide some context to the model with your questions. So what I mean is, let's go here. The main thing here is combining query and context. Let me try this one, combine query and context. So we can retrieve context from our data sets. So let's say you have a data set of huge volume of PDF. What we can do is, based on our questions, we can collect some relevant data and we pass that data to the model. Then the model uses its reasoning capability and it can answer really well. So that's the entire goal of today's session. I hope this is clear. So I helped try to see why context is important, and we will learn about other things now. Maybe before going to the actual project, what we can do is we can try to find some API key, because in our, even though it's a private document analysis, I have explored few OpenAI based models, so we can make a comparison of it. So let's say you have a project that uses maybe private, and maybe if let's say you want some higher accuracies, you can use GPT-4 or GPT 3.5. In that case, you can use the same code base and try to modify things. So let's go to here. So when you click personal, I think view API keys, click that. Here you can create a secret key. Just click this and you can type some name, and if you click create secret key, you will get a key. So copy the key, and if you are trying to follow my code, and what you can do is just click this folder. Here I have created a text file called keys.txt. Open, maybe create that keys.txt and then paste your key there. So that's the one thing you have to do so that you can follow along with me. Cool. So now I have set up the project, which is this collab, and then I have loaded my keys. Now let's talk about the dataset. So what I have done here is I was watching this talk recently, State of GPT. So you can click the transcript here. When you click the transcript, you will get a Word document. Then I converted that Word document to PDF, and then I uploaded that document in our Slack channel, karpathy.pdf. I think this PDF is like 16 pages. So what we are trying to do is we will use this document to build some project on that. So this is his transcript. So this is a great talk. Here he talked about the technical details of the model as well as some general suggestions on how to improve, how to create a prompt and how can get the best out of these models. Cool. By the way, I also try to have written a talk about these things. So Karpathy talked about these 10 useful information. I try to explain that and then with some examples. Maybe I'll share that in our Slack as well. I thought it's super helpful. Cool. Now let's go to project. So I have installed a few libraries. I will talk about all these libraries as we go, but now you can follow along with me. So I used LangChain. Maybe before talking about the code, let me try to talk about the process. You can watch my right hand side, and then once the process is clear, we will dive into the code. Cool. Okay. So now what we are going to do is we are trying to understand the general recipe of chat with PDF or chat with data projects. So let's say you have a document. The document can be PDF, image, audio, or it can be like Slack messages, WhatsApp messages, anything. It could be anything. What we can do is we can extract text from it. Once we know how to extract text from those documents, we can make use of it because we are playing with large language models. So it needs text. So the goal here is to convert PDF or any dataset to text. I have also written something here, which is some terminologies that LangChain uses. We call this as document loader. Maybe I will talk about these things as well as I will do some comparisons. So this process, loading the document, is called document loader. And if you go to LangChain library, they provide lots and lots of ways to load documents. I heard that they provided like more than 100 different ways. You can use PDF, Pandas data frame, Microsoft Word, and so on. You can see it here. So for our session, we'll be using PDF. So that's one thing. This process is called document loaders. Then we run that code, then we'll get the text. Then the next thing is, maybe I didn't talk about this yet. Maybe let's go here for a second. This one, go back. So here, let's say we are providing some context, right? So let's say the context length is really large. For example, let's say I have a 16 pages of PDF, and then if I paste all the content here, what happens is we won't get any result because there is a token size limit. I think the token limit is like close to 4,000. So your token size limit is more than 4,000 tokens. We cannot run any model. So what we can do is we can split the main big document into small chunks. We call this as text splitters, small chunks. So chunking is important. Now let's go up here. Okay. So chunks. So we call this as text splitters. Then once we created small chunks, what we can do is we can create some embeddings for those. So embeddings means converting text to some vectors. So there are libraries that provides these things. One is OpenAI embeddings, Hugging Face embeddings, SentenceTransformers embeddings, and there are many more. So if you go to LangChain embeddings, here they shared different ways to get embeddings from text. You can have a look. So for our project, we will be using 3 different embeddings. For one part, I used OpenAI embeddings, and for other parts, I used Hugging Face embeddings and SentenceTransformers embeddings. So there are we will be exploring with 3 different things. So in this embedding convert text to numbers. Then what we do is we store these embeddings somewhere. That process is called vector store. So there are so many vector stores available. If you go to indexes and vector stores, and you can see some of the different ways to store and retrieve these details, embeddings. For our project, we will explore FICE, which is from Facebook, and then we will be exploring Chroma DP. So we will do these 2 things. So, and other popular thing is Pinecone. So Pinecone, FICE, Chroma. So we call this process as injection step. So in injection step, what we did is we have a data set, which is a PDF. Then we extract the text from it. Then we divide the large volume of text into small chunks. Then for each chunk, we create embeddings. Then we store that embeddings in some vector store. Now I'm going to talk about some public access and private. So there are many ways to create embeddings. So if you are using OpenAI embeddings, which means you are using OpenAI API endpoints, you are passing your data there and you will get some embeddings. Let's say you don't want to do that. Let's say you want to secure your data, you want to use your own private setup and you don't want to use any internet. In that case, you can download SentenceTransformers embeddings or Hugging Face embeddings, and then you can store everything locally. Then you can call the model and pass your data and you will get the embeddings. That's one thing. And there are many ways to store embeddings, which is vector store. This Pinecone, I think that's like a public one, which is online. You pass all your data there and it's stored there and you can retrieve from there. So for some datasets, there is no issue there. Let's say you want to use your local setup. In that case, you can go with FICE or Chroma options. So in private GPT, what they do is they try to choose these private options. One is Chroma and other is SentenceTransformers embeddings, I guess. Let's go here. So this is PrivateGPT, and you can see what are the tools they are using. So LangChain GPT4All, which is a model, and this is for getting embeddings and storing embeddings, Chroma, and they are using SentenceTransformers as well. Cool. Now let's go back to the code. Okay, so in the injection step, we have done from document to vector store. Then retrieval step. So this is the second part. Maybe let's go here for a second. Previously I showed an example where I provided some weather information like Sydney 15, Brisbane 20, and Melbourne 13. So we are collecting some relevant context and passing it on our question. So the main goal is we have some question. The question is what's current temperature in Sydney, and we will collect some relevant context. Then we combine these two and we pass these to language model, and we will get some results. So to do that, what we have to do is we have our question, right? So question could be what's current temperature in Sydney. Then we can convert embeddings for this question. That's the first step. Then what we do is we look up similar embeddings from our vector store. Let's say there are 30 different documents in our vector store, and let's say 3 different documents talking about temperature. So you will get some close distance. So you can collect those information as a context. Then we pass these two things and we combine query and context. Then we pass to the model and you will get results. So that's the overall architecture. Maybe now let's go to the code and we will understand one by one. So if you have any questions, please ask on ask on Slack. Yeah, Slack is better. Cool. I also shared this notebook on Slack. You can also use that. After this session, I will update on YouTube with my notebooks and other details. Cool. So as I have showed library a little bit, like LangChain. So in this project, we are touching many different components. For all these connecting parts, we can use LangChain library because LangChain library supports these things. As you can see here, it has lots of document loaders and it provides ways to split your documents into chunks. Then you can store that in any vector store. Then we can retrieve the details. I think on YouTube, Mike is asking, can you share the Slack invite? Maybe I will ask Tim to reply. Tim, could you please share Slack invite on YouTube? Thanks. Okay. I think few people are requesting about Slack invite. Maybe don't worry about that for now. After this session, I will make sure you got an invitation. Meanwhile, after the session, I will also share all these details on YouTube. So don't worry about it for now. So rather than PDF, can you include some more recent web scraping? Yeah, we can do that. Maybe in one of our future session, we are planning to develop some LangChain agents and ChatGPT plugins. For that, we will touch all these things. Thanks, Leo. Also, the approach is very similar because we are using document loaders. How we are loading PDF, which is same as loading some HTML page. There is no difference there. Because this one of the powerful thing about LangChain is it provides lots of abstractions. We can make use of it. Now let's go back to the code. So as I talked about LangChain and then OpenAI library. So OpenAI, we will be using OpenAI library for two things. One is retrieving some embeddings for text, and then we can make use of GPT 3.5 and GPT-4 model if you have an access. Cool. I have also included some standard imports let's say you're trying to extract some data from image. In that case, you need to install these libraries, Detectron 2 and few more. So this is like a standard thing. Just run. Okay. So here you can pass your key. So as I told before, you can find your key information from platform.openai, and you can put it here, or if you want, you can also share like this. Create a file keys.txt and then put it there, and you can load it from there. Okay, let's close this. Let me check this. Let me read one by one. There is a, okay. What would the pipeline look like for PDFs that are forms? Example, if you want to build a QA model for querying internal documents in a company. So let's say there are forms. Still, even though if it's a form, we can extract some information from the form. Let's say you have like hundreds of PDF, you can follow similar approach. I can talk about that in detail as we load the PDF. Okay. Cool. I think this is an example I used in one of my previous session. So this is invoice, this is JPEG file. So we will try to extract some information from this file. To do that, we use unstructured image loader from LangChain, and you pass the image name. And if you do data equal to loader.load, you can get the data. Like it extract all the information from this image, and you can see all the information here. Then once this data is ready, what you can do is you can pass this data to the model as a context. Then you can get answer. Cool. So this is a small document. Since this is small, we can pass all the document at once. There is no need to split. So if you see some of my code, I have initiated OpenAI model, and in LangChain, there is a function called load QA chain that takes a large language model, and there are some chain type. I will talk about those chain types as we go. Stuff means we pass all the data at once to the model, means stuffing all the data to the model and get some results. If the dataset size is less, means like less than 3000 tokens, what you can do is you can pass all your document as a stuff. But there are many chunks. I will talk about those, how to solve those things. Since we have created this QA chain, we can ask some question. So create a title for this document, use build to. So it says ACME Industries build to bench accounting. So if you see the invoice, you can see this is bench accounting from ACME Industries. Now what's the payment due date? It extracts those due date, and you can see the answer and summarize this document. Here it try to summarize the document. So this document is an invoice from bench accounting to ACME Industries for 10 chairs. The chairs cost 500 each for a subtotal, and you can read it here. So this is helpful. And what's the shipping address? You can see the address. So let's say you have 100 different any bill or receipts. Let's say you want to extract how many times you have got some Uber bill or any bills, and you can automate that process, load all the data and ask questions one by one and retrieve details. Let's check here. Okay. So now let's go back to PDF question. So we have uploaded our PDF, karpati.pdf. I extracted from here, as I told before. Now, okay. So now what we are going to do is we are going to do all these things from document, extract text, small chunks, create embeddings, store the embeddings as a vector store. To do that, we need to install few libraries. This is for vector store, FICE, and this is for embeddings, sentence transformers. And here what we are doing is we are using recursive characters text splitter. So which means it splits based on paragraph, then it splits based on space, then it splits based on each word, each letter. Then for embeddings, we use OpenAI embeddings and sentence transformer embeddings. And we'll at the end of the session, I will show you a few more techniques too. Then this is PDF loader. We imported by PDF loader. And for vector store, we are using FICE. Since this is a PDF, we use by PDF loader.load, and it loads all the pages. There are 16 pages. Then what we did is, since there are 16 pages, we cannot pass all the information to the model at once. So we have to use text splitter to make small chunks. So I have mentioned my chunk size is 300. So which means it takes 300 characters and create as a first document. Then I used chunk overlap 30, which means 30 character from end of first document will be overlapped to the second document. You can see some example results here. Then after that, what we did is we split the document into many chunks, which is split documents. Then we store everything as a embeddings. I used two approach. For now, let's focus on OpenAI embeddings, and then we will use some private embeddings. So currently I'm using OpenAI embeddings. The approach is very similar. There is not a lot of change. Cool. Then retriever. So this retriever has know how to retrieve information based on the text. We will connect these things in a chain. I will show that at the bottom. So currently, after creating chunk size as 300, which means 300 characters can be split into a document, there are 175 documents now. Earlier it's like 16 documents. Now it's 175 documents. Each document is like 300 characters. And if you see this document, it says, so I would like to partition the talk. The same information is here too. Like to partition the talk, because we used 30 character as a overlap, chunk overlap equal to 30. So you can see it here. So now I have a retriever. The retriever is this one, db.asRetriever. Now I can get relevant information. For example, let's say what are retrieval augmented models. So Karpati was talking about this one, what are retrieval augmented models. I can get information from it, like retriever.get relevant documents. You can ask your question and it finds the similar chunk, and you can see there are 4 documents that talk about those things. You can read these later. 1 second. Okay. So now we know how to find relevant information from the questions. So this step is like this part. Let me write this. So our question is this one, what are retrieval augmented models? When you use retriever.get relevant documents, what's happening here is we create embeddings for our question, which is what are retrieval augmented models. Then we find the top 4 similar documents by looking up the embedding with similar scope. Then we combine these 2 things and we can pass that to the model. We will see that next. Yep. So initially, instead of using private models, I am using chat OpenAI. So in chat OpenAI, I have used 3 different models. One is GPT4, I think it could be 3.5 turbo. Okay, maybe we might get some error if I made any mistake here in the typo, but we'll fix that. So I used 2 models here, GPT-4 and GPT 3.5. My advice or suggestion is, let's say the question is easy In that case, you can use 3.5 model or any other lower end models. Let's say the problem is super challenging one. In that case, you can use GPT-4. GPT-4 is a little bit expensive compared to GPT 3.5 Turbo. So based on your use case, you can play with private or GPT 3.5 or GPT-4. Sometimes you can also combine these three things. For example, let's say you can use a private GPT model to find if there is any private information in the data chunk or questions. If there is no private information, you can call external models. If there is any private information, strictly call local models. So you can write code to optimize these things. So that's why I have provided many options. Cool. So now the question is, what are retrieval augmented models? Maybe let's use LLM3 for now. I might get error. Let's see. Yeah, there is no GPT 3.5 Turbo. Maybe let's Google this. Okay, so this is this one. I made a typo there. Okay, and there is a hyphen. Okay. Okay, so now what's happening is we are chaining two things. One is, first of all, maybe let's talk about one by one. So since this is question answer, I am importing this chain, question answering chain, load QA chain. Then I have passed my model LLM3. Then I passed about chain type. There are 4 different chain types. Stuff means stuffing all the document at once to the model. Then this document will have 4 different documents. Maybe let's print this. Print docs. So you can see it here. So documents are here. Let me, okay, it's difficult to read, but you can see it here. So this is this print. Maybe let's use, okay, so these things are document. So this document comes as a context to the model. So the model has access to these information, relevant chunks. Then based on relevant chunks, we can try to get answer by passing these 2 things to the model. So in the model, we passed 2 things. One is our question and relevant documents. So that's this step. This one, query plus relevant context. So that's our goal, and we achieved that one. Okay. So the answer is here. Retrieval augmented models are a type of machine learning model that can retrieve information from a large database or knowledge base. Okay, you can read it here. And I use the same question with GPT-4 model. Sometimes we might get better results in GPT-4. So GPT-4 is a little bit expensive compared to GPT 3.5. How would one go about choosing a value for the text overlap size for the splitter? Actually, it depends on the context. I recently came to know that chunk size 300 and chunk overlap 30 or 50 works really well. I read this on Twitter. Maybe let me find that. Likes. Yeah, it's here. So Wade Gilliam, he shared context size 300, or let me read it here. Yeah, he says when splitting your text for embeddings, chunk them in sections of 150 to 200 tokens with an overlap 0 to 30 tokens. I think I used 300 and then I used 30. So it depends on the use case. His explanation is this represents an average paragraph in English, and assuming a paragraph is usually about a single subject, this should improve vector-based similarity search. So previously I used to chunk like 1000 characters at once. I think 150 to 200 tokens. So it should be more than. So we are using character limit. He is talking about he is talking about token. So 150 to 200 token could be like 500 characters, something like that. So 300 to 500 might be a good number for character split, and chunk overlap, maybe you can play with 30 to 50 or something like that. Thanks, Vivian. Good questions. Okay, so here LLM4, you get some detailed answer. And what did Karpathy talk about? System to thinking. And he talked about system to thinking in few documents, and you can see the answer. So Karpathy discussed system to thinking in relation to AI models and other things. Cool. You can read this later too. And one of the discussion is, maybe let's go. So one of the discussion is about tool use. He says this involves augmenting the capabilities of the model by giving it access to specific tools or external resources such as calculators, code interpreters, or internal search engines. So I try to find these things, how external tools like calculator improve the model result. Then this is the answer I got. External tools like calculators can improve a model's result by providing more accurate and reliable computations, especially for complex arithmetic operations. So this is helpful. Cool. So far what we have done is we used OpenAI embeddings, and then we used OpenAI models to get some results. But we stored all our vector stores as local. We didn't use any online vector stores like Pinecone. So now we will explore private large language models. So especially we will focus more on GPT4All, this model, GPT4All. This one, GPT4All. Sorry, GPT4All. Good. So this model size is like 3.5 GB, something like that. We can download this model and store that on local. So I have downloaded two large language local models. One is GPT4All Snoozy model and GPT4All Groovy model. So there are different names with different results. So I played with these two models. Cool. Maybe I'll show you how to download the model first. So I went to this document, GPT4All, and here they provided code to download the model directly from this website, GPT4All.io. Yep, GPT4All, yeah, free to use, locally running, private aware chatbot, no GPU or internet required. And if you go to the bottom, they provided different model types. I played with Groovy and Snoozy. And if you click Snoozy and click this button, you can download that on your local computer. I'm not going to do that. Cancel. Close. Okay. So if you run this code, the model will be downloaded, and for me it took like 1 to 2 minutes, and then you can access the model locally. So I was playing with few different local model options, but the problem I faced is to generate some output, it's taking like 1 to 2 minutes, sometimes longer. So after that, my plan for any project is, if it has some private data, I will try to stick with private GPT options, or if it doesn't have any private data, you can use any models like OpenAI and other options. Cool. So after downloading the model, you can use this one, GPT4All, and you can pass the model path, and then you can, this is different backend, LLM private. So far we have created 3 models, LLM 3.5, LLM 4, and LLM private, and we can follow same approach. We have some question, then here I try to do the same steps, but previously we used OpenAI embeddings, but now I'm sticking with SentenceTransformers embeddings, which is private and local. So we are storing everything on my Google Colab, or you can also use your local computer. Since I'm going to share my code, I use Google Colab. If you want if you want to work with models without any internet, you can use your own computer. Yeah, that's an option. Cool. So now what's happening here is we have a text. Then this is our document. We divided the document into many chunks, and then we store everything as a files vector store using SentenceTransformers embeddings. Previously we used OpenAI embeddings, but now we are using SentenceTransformers embeddings. Then when you have a question, what are retrieval augmented models? We are retrieving the relevant documents here. Then we are passing our model as well as this question. This we are chaining two things. One is relevant documents, and other thing is our question. Then we run this, we get the output. To get this output, it took me like 3 minutes. So this model, I think there are some options to use this model on GPU that could be faster. Or if you don't worry about the time limits, you can strictly go with private options, and you can wait a little bit longer. So this is some of the examples answer. Yeah, this looks good too. So far we learned a few things, 2 different ways to create embeddings, OpenAI embeddings and SentenceTransformers embeddings, and we played with GPT 3.5, 4, and private model GPT4All. Now I will show you a few other things like Hugging Face embeddings and Chroma DB. So this is same approach. Instead of OpenAI embeddings or SentenceTransformers embeddings, I'm using Hugging Face embeddings. And Hugging Face has so many model embeddings, and you can pass the model name and it will download those things. Once it's downloaded, it can be local. You are not passing anything to the cloud. You are retrieving and playing with all the details on your local computer. Then previously we used files vector store. Now we are using Chroma. The approach is very similar because of LangChain abstractions, which is super helpful. Previously we used files.doc from documents. Now it's Chroma from documents. The approach is very similar. So here, these things I tried to play with it. You don't need to worry about that. Yeah, I think we are pretty much done. So this is a short session, but still I hope this is super helpful because we played with few model options and the code is full working code. You can use this for your own projects. I hope this is helpful. If you have any questions, please ask on Slack. I think GPT-4 needs a paid account. Yes, it needs a, I think even 3.5 and 4 needs a paid account. For GPT-4, you need to get an access, like there is a waiting list for that. Maybe if you don't have access to GPT-4, you might get error when you use GPT-4 model. In that case, change this line to LLM 3. It should work. So everyone has access to LLM 3 if you have a OpenAI account. For GPT-4 model, there is a waiting list, and yeah, there are some options. Thanks, Tim. Cool. I will stay here for a few more minutes. If you have any questions, please post it on Slack. I will answer it here. Otherwise, see you all next